Yes, this is a really fascinating question, and a lot of people don't realize that many drugs that we still use today, many current drugs, are derived from natural organisms. So penicillin is the one that many of you might have heard about, that was discovered by Sir Alexander Fleming. He was growing bacteria on a little petri dish, on a little colony in the laboratory, and he also saw this little colony of fungus, and he noticed that within a certain distance of the fungi, right, it was just like this hairy little fungus colony, that no bacteria were growing there. And so he isolated the agar, which is the media that it's growing in, from right around the fungus, and he did various experiments, and he was able to demonstrate that there was something in that material near the fungus that killed bacteria, and then later he was able to isolate it. That's where penicillin came from, and many antibiotics are derived from fungi. Now, why would a fungus make some compound to kill bacteria? I mean, that's kind of a neat question, right? But again, that's a beautiful example of an ecological interaction. What do bacteria eat? Well, they eat rotting material, right? They're eating rotting organic matter. But that's also what fungi consume to get their energy, right? They also use rotting organic material, dead bodies of organisms and dead plant material. And so they're fighting, or they're competing, is what way we call it in ecology, right? Just like a lion is competing with a hyena to kill the same animal to eat for dinner in Africa, a fungus and a bacterium are competing to utilize the same food source. And so when the fungi evolved a compound that could kill bacteria, there's no better way to get rid of competition than to kill your competitor, right, in a natural scenario. And that's exactly what fungi do. There are other interesting sources of compounds like this, not just antibiotic compounds, but I'll give you two cool examples, again, based on research that ecologists have done. One is in amphibians. Amphibians have a moist skin, and not like a reptile, right? Amphibians are things like frogs and salamanders. Many of you have heard of frogs and salamanders. And that wet skin is, it's just like your skin, except it's very wet. And so those kinds of organisms, they can't help it. That's the kind of skin they have. But that makes them very vulnerable or open to getting infections, right? Because lots of things would like to live on and eat nice moist skin. And it turns out that amphibians have evolved the production of many kinds of antimicrobial compounds, sort of like antibiotics, that are secreted by special glands in their skin, which kill bacteria. And this was only discovered in the last, 6 or 8 or 10 years. And now there are biomedical researchers that are going out in the world and finding different species of frogs and salamanders and trying to find these compounds and bring them into the laboratory and study them, try to understand how they're made, what the chemical structure is, and so on. That's one cool example. Another example of a compound that we derive from the natural world is various kinds of painkillers, right? Many of you have heard of opioids, right, which is a powerful painkiller. Those come from a plant, right, the poppy. But there are other kinds of pain-killing compounds and compounds important in medicine. One is called curare, which is a muscle relaxant that's at least historically been important in surgery. When they're doing surgery on you, they have to relax your muscles, and that comes from a frog. And there's also a new compound, or several new compounds they've discovered in poison arrow frogs, which are these frogs from South America. Some of you have probably heard of those. They're very colorful and bright, and they secrete compounds in their skin. And the reason they have those compounds, the reason they evolved those, is so that if something eats it, it spits it out, because it's distasteful and makes the thing that ate it sick. But it turns out that some of those compounds are very strong painkillers. And people are working hard to try to find additional compounds like that. There's a compound from poison arrow frogs that is something like 50 times more powerful of a painkiller than morphine. Morphine is the most powerful painkiller that we currently have in modern medicine. So there are lots and lots of examples like that of things that we borrow from nature because nature solved a problem and we have the same problem, and we can go find that solution and use it for ourselves.